Welcome to this explainer. Today, we're cracking open the Post-Nord Engineering Handbook to bring you a complete masterclass on AI-assisted software development. We are going to transform you into a highly disciplined, incredibly effective operator of GitHub Copilot and AI agents inside your enterprise repositories. We are moving fast today to map out exactly how modern engineering teams are safely harnessing AI without sacrificing an ounce of security or architectural integrity. Let's get to it.
Here's our roadmap for today. We'll start with core operating principles and the customization matrix, then move through the modern AI-assisted SDLC. After that, we're tackling a really critical security threat model, followed by step-by-step file setup, IDE compatibility, and finally, governance.
All right, Section 1, Principles and the Customization Matrix.
So these are the foundational rules of engagement that govern this entire framework. And the most crucial point here, the absolute non-negotiable, is that prompts, agents, and instructions must be treated with the exact same rigor as your production infrastructure code. This isn't just about casually chatting with a bot anymore. This is about treating AI customization as version-controlled engineering assets. You always want to use the narrowest AI customization possible, apply the principle of least privilege, and mandate human approval for any architectural or security decisions.
Now you might be wondering, when do you actually use what? Well, the customization decision matrix basically maps your specific engineering need to the right mechanism. For example, if you just need a stable baseline behavior across your whole repository, you stick with repository instructions. Simple, right? But what if you need external context, like reading Jira tickets or pulling Azure logs? That's when you spin up an MCP server. This heuristic keeps things incredibly organized and ensures you aren't over-engineering, like building a custom agent when a simple path-scoped instruction would have solved the problem with way less overhead.
Moving right along to Section 2, the modern AI-assisted software development lifecycle.
We really have to draw a hard line here between automation and engineering judgment. Think about what AI is amazing at: scaffolding, generating boiler code, throwing out candidate architecture options, maybe exploring gaps in your test coverage. But on the flip side, you have human accountability. And remember our recurring theme for today: AI proposes, but humans decide. You, the engineer, are ultimately accountable for domain correctness, assertion quality, and production safety. AI is your assistant. It is absolutely not your replacement.
Okay, Section 3, the AI security threat model. You'll want to pay close attention here.
We need to talk about some novel security threats that your traditional linting and scanning tools are going to completely miss. Take indirect prompt injection, for instance. This is wild. This is where malicious instructions are secretly embedded inside external files or wiki pages. If an AI agent reads a poisoned Jira ticket or a compromised Confluence page, maybe someone hits some white-on-white text in there, it could silently generate a malicious workflow file without you ever typing a single malicious prompt yourself.
And then there's MCP tool poisoning. The Model Context Protocol is what allows Copilot to interact with external tools. But think about this. What if a malicious entry sneaks into your local mcp.json file? It could literally instruct the AI to read your workspace secrets and quietly post them to an external server. You have to treat the addition of an MCP server with the exact same suspicion as adding a brand new, unverified third-party dependency to your production code.
Here's another completely new vector: slop squatting, otherwise known as hallucinated dependencies. Sometimes Copilot gets a little too creative and suggests a package name that doesn't actually exist on public registries. Well, attackers know this. They actively look for these common AI hallucinations and they pre-register those exact names on NPM or NuGet. So, if Copilot suggests a package and you just blindly copy-paste that install command into your terminal, you could be installing malware. Never, ever install an AI-suggested dependency without verifying its existence on the official registry first. No exceptions.
So how do we defend against all this? You need to follow this defensive playbook religiously. First, never paste raw external content directly into chat. If you're using agents that operate autonomously, you must perform line-by-line diff reviews of all their output. Do not just auto-commit that code. And here's a hugely important tip. Close all files containing secrets, like your .env or appsettings.json, before using the workspace context. That way you don't accidentally leak your credentials right into Copilot's chat responses.
That brings us to Section 4. Let's get hands-on with the step-by-step file setup.
First up is establishing your baseline. You're going to create a .github directory right at the root of your repo and place a copilot-instructions.md file inside it. This creates a persistent repository-wide baseline. Copilot reads this file at the start of every single chat session. It doesn't need any YAML front matter, just plain Markdown.
This is exactly where you put your global rules, like, always use result objects instead of throwing exceptions.
But what if you have a massive mono-repo? That's where path-scoped instructions save the day. You create an instructions folder inside .github. Now, these files do use YAML front matter with an apply to glob pattern. This is brilliant because it lets you enforce your React rules specifically on the front-end folder and your .NET rules exclusively on the back-end folder, all without polluting the AI's global context window. When you open a matching file in your editor, Copilot just dynamically loads those specific rules.
For custom agents and prompts, you'll create a .agent.md file in an agents folder. This one requires YAML front matter defining the agent's name and what tools it has access to. Agents are absolutely fantastic for establishing bounded expert roles. For example, you could create a security auditor agent that is explicitly restricted to read-only access in your workspace. Then, you just invoke it directly from your IDE picker whenever you need a security review.
Now pay close attention to skill.md files, because they behave differently. Unlike repository instructions or path-scoped files that just load up automatically, skills are essentially multi-step operational checklists, and they must be explicitly invoked. You literally have to type into the chat using the skill name procedure, or attach the file directly to your prompt just to activate those specific steps.
All right, Section 5, IDE compatibility and migration.
Here is where things get a bit fragmented, depending on your local development environment. Visual Studio Code is the definitive reference environment here. It is fully supported. Visual Studio 2022 is highly version dependent, so you have to keep it updated. Meanwhile, JetBrains IDEs like Rider and IntelliJ only have partial support right now, or are still in active development for some of the more advanced features, like those custom agent pickers we just talked about.
Because of these discrepancies, if your team is spanning multiple different IDEs, you desperately need a migration strategy. Rule number 1, keep absolutely all of your customization in the .github folder. Never, ever put portable settings in a .vs Code folder. Stick to simple glob patterns because the really complex ones might actually fail in JetBrains. And hey, if your IDE doesn't support an agent picker yet, don't worry. Just invoke the agent by attaching that .agent.md file directly in the chat using the #file command.
And finally, Section 6, governance and change control.
Any changes to these AI customization files demand strict, rigorous change control. Seriously, think about the blast radius here. A compromised Copilot instructions.md file acts as a silent, team-wide supply chain attack. If an attacker sneaks just one malicious line in there, every single engineer on your team will have poisoned AI output instantly. That is exactly why these files demand the exact same PR scrutiny and branch protection as a critical production backend change.
Which brings us perfectly to your definition of done for any AI-assisted change. Look, it is not done just because the AI's code happened to compile. Your requirements must be traceable, your tests must pass, security checks must be totally clean, and a human reviewer must approve it. Your definition of done is the guardrail that ensures AI velocity never outpaces your engineering compliance and testing gates.
I want to leave you with this final, provocative thought to truly solidify our human accountability rule. If a hallucinated dependency sneaks into production, whose commit is it anyway? The answer is yours. AI is an incredibly powerful assistant. It can write your boilerplate, it can suggest brilliant architectures that at the end of the day, the Git history bears your signature. You are the engineer in charge. Thank you so much for joining me in this explainer, and happy secure coding.